everyone, welcome to GEMCHEM. Now today's video is on alkenes part 13 video, and here we are going to deal with syn and anti-hydroxylation in two different other methods. Now in the previous video we have already dealt with the hydroxylation using OSO4 and MnO2. Now here we are going to deal with Prevost and Woodward reaction. Now before starting, if you are new to GEMCHEM, do not forget to subscribe the channel and hit the bell icon for regular updates. Now let us start. Now what do we mean by Prevost reaction? Here the reagent is the iodine and AgOCOPH, and these two are taken in the ratio of 1:2 and we get an antidiol product. If you see this reaction, this is an alkene, and or adding this reagent followed by hydrolysis, there is formation of an antidiol product, and this method is known as dry method as there is no usage of water in the first step. So this is the mechanism. If you look into this, so here electrophilic addition occurs. Now we have already dealt with how electrophilic addition occurs. Now this double bond is being donated to the iodine and iodine becomes I+. Now OCOPH has a negative charge on it. This attacks this carbon center and the bond here opens up towards the I+. Now in the next step, this SN2 attack is being done, and here neighboring group participation occurs. Which is the neighboring group? This part is our neighboring group. This participates in the reaction to remove the iodine. This oxygen just attacks the carbon using its lone pair and the iodine leaves the site. Next part, here we see that again another moiety of OCOPH minus attacks this particular carbon, and then this oxygen carbon bond opens up. Ultimately we get this kind of product. This on being hydrolyzed, we ultimately get the antidiol product. Here, now see, this is the Woodward reaction. Here the reagent is same, but there is certain difference. Remember, here we will use in aqueous acetic acid. If you carefully see here, it was dry benzene, but here we will use aqueous acetic acid, and here it is used in 1:1 ratio, AgOCOCH3, and here we will get syndiol product. Since there is involvement of water, this method is known as wet method. Now see here, for the first two steps this is same. Then if we come to the next step, that is third step, we see that here oxygen of the water attacks this carbon attached with the CH3 oxygen and double bond oxygen. Then this oxygen opens up. Ultimately we get this kind of moiety. This further on losing proton then gives us this product. This on being hydrolyzed, we ultimately obtain our syndiol product. So this is quite different from the previous one which we have seen. So this is the main difference between Prevost and Woodward reaction. Now this is one of the examples. Here you can see that here a double bond is present. As you add AgOSC, iodine and water, then in one step only there is formation of syndiol. But when the water is added in the next step, we get antidiol. So this much for today. Hope this was helpful. Thank you for watching. Do not forget to like, share, subscribe and comment.